Okay, as promised, what if the power of sine and cosine is not odd? What if it's even? Well, okay, let me try it first. You know, I'm stubborn. I'm gonna go after it. So I'm on a test. I'll go, okay, I'll leave the sine squared 3x. I'll take off a cosine 3x. And there I'm taking off another in order to do a substitution. And that would be my du. So I want u to be sine of 3x. And so he's good, but I cannot get him to be a form of sine at all. And so this is a dead end. Okay, so we have to be doing something completely different. And what's completely different is we reach into our trig bag of tricks, and we're going to use an identity. There's two identities. One is sine squared of, let's say, theta, and cosine squared of theta are what? Half angle, double angle identities. I forget what they're called, but their relationship is you go from a single angle to a double angle. So I'm going to call it a double angle identity. They're almost identical. They both start off with 1/2, and then inside is a 1 and a 1. And the only difference is that sine, I'll do this in red, sine has a minus and cosine has a plus, but the rest is the same. That is to say, inside here is cosine 2 theta. Cosine 2 theta. How does that help us? Well, if we're in the midst of trying to integrate an even power and I don't know how to get that 2 power down to a 1 power, this is the way. So these are nice identities to use. In fact, that's what they teach you in all calculus classes to use when taking on this problem. We have no choice. You saw that this is a dead end. So what we do instead is we take the sine squared and we use the first identity. We go, well, it's the integral of 1/2, 1 minus. Now this is where students have to pay attention. Our angle in here is 3x. It plays the role of theta. When I use this identity, we get double theta. So when I use the identity in our problem, we get double 3x, and that gives us 6x. Okay, and then you can pause there and ponder that one. We do the same thing here. 1/2, 1 plus cosine 6x dx. Well, you can integrate, except we have a product, and that's kind of a pain because look what happens. I'm going to take the 1/2 times the 1/2 out and make it 1/4. And inside, I'm going to FOIL that all out. And you know what I'm seeing is a difference of squares. So we're getting 1 minus cosine squared 6x dx. We're making headway, believe it or not. I can integrate the 1. I get x, okay? But integrating cosine squared, guess what? Got to use this identity again. So let's rewrite it. We're going to go, it's equal to 1/4 integral 1 minus, here comes, 1/2, since it's cosine, 1 plus, and then cosine of, it goes from 6, believe it or not, double it to 12x. Okay, dx. Okay, wow. I'm going to distribute the 1/2, and I'm going to collect like terms. Well, I'll show you. It goes 1 minus 1/2 cosine 12x. That's what we're dealing with. So I'll put the 1 minus 1/2 together and go, I've got 1/4. I'm going to be very careful here. 1/2 minus 1/2, and then cosine of 12x dx. Now, this is just integration stuff. Breaking it down to here, now it's in your wheelhouse. You should be able to integrate it pretty well. I'll just go kind of quickly. I'll go 1/4, big old bracket, 1/2 x. I might have thought to take the 1/2 out, but I left it. And then minus 1/2, and now I'm going to integrate cosine 12x, is where you go let u equal 12x, du is 12 dx, so therefore you end up with a 1/12 in the problem. Okay, so you got times a 1/12 integral of cosine is sine of 12x. Now I feel safe since everything's integrated. I'll do the plus c. And now I will plug this all in and say I got 1/8 x. I'm distributing the 1/4. I got, what in the world? I got 24, I got 80, 96, so minus 1 over 96 sine 12x, and then plus c if my numbers are correct. So that's what you do. If it's even Steven, if it's even powers of sines and cosines, okay, that's the deal on that one, okay? Next stop, secants and tangents. Looking forward to it. Oh yeah, it's good stuff.